Now this is Euclid Book 6, proposition number 23. And it says, equal angular parallelograms, boy that's a big one, have to one another the ratio compounded of the ratios of their sides. Okay. Let AC and CF, well, where's AC? Well, AC is this parallelogram right here. And CF is this parallelogram right over here. And they have to be equal angular. Well, this one's equal angular to that one, trust me on this. Okay? And they have the angle BCD. Well, here's B, here's C, and here's D. This angle right here. Okay? That one right there is equal to the angle ECG. Well, where is ECG? Well, here's E, here's C, and here's G. This angle right here. So this angle here equals this angle right here. So far, so good. I say the parallelogram AC, this one here, has the parallelogram CF, this one right here, the ratio compounded of the ratios of the sides. For let them be placed so that BC is in a straight line with CG. Well, here's BC, this one right here, and this is CG right here. Therefore, DC is also in a straight line with CE. Well, here's DC, this line right here, and here's CE way down here. Let the parallelogram DG be completed. Well, here's DG, there's the parallelogram DG, and it's now completed. Let a straight line K, now where is K? K is way over here. Here's K right here. Let a straight line K be set out and let it be contrived that as BC is to CG, well, as this line here is to this line here, so is K to L, as K is to L. As this line is to this line, so as this line is to this line. So far, so good. And as DC is to CE, well, where's DC? Well, there's DC right there, and there's CE right there. As this is to this, so is L to M. Well, here's L here, and here's M here. And this is by Euclid Book 6, proposition number 12. Then the ratios of K to L and of L to M are the same as the ratios of the sides, namely BC to CG and of DC to CE. So, the ratios of K to L, K is to L, and L is to M, are the same as the ratios of the sides, BC is to CG, and of DC is to CE. But the ratios of K to M is compounded of the ratio of K to L. The ratio of K to M is compounded of the ratio of K to L. And that of L to M. Okay? So that K also so that K has also to M the ratio compounded of the ratio of the sides. Now since as BC is to CG, so is the parallelogram AC the parallelogram CH. Well, AC, CH. As this line is to this line, so is this parallelogram to this parallelogram. And this is by Euclid Book 6, proposition number 1. While as BC is to CG, so is K to L. Therefore, also as K is to L, so is AC is to CH. As K is to L, so is AC to CH. This is to this, so is this to this. And this is by Euclid Book 5, proposition number 11. Again, since as DC is to CE, So is the parallelogram CH to HF. I'm sorry. As DC is to CE, as DC is to CE, so is the parallelogram CH to CF. CH to CF. Wow, as DC is to CE, as DC is to CE, so is L to M. L to M. Therefore, also as L is to M, so is the parallelogram CH to parallelogram CF. CH, CF. Therefore, xi quali as K is to M, so is AC to CF. AC to CF. But K has to M the ratio compounded of the ratios of the sides. Therefore, as AC also has to CF, as AC has to CF, the ratio compounded of the ratio of the sides. Okay. That's a lot of work there. Now, let's start with the ratio of BC to CG in this case. Okay, now I'm going to write down some numbers here. BC to CG has a 2 to 3 ratio. Okay. And K to L also has a 2 to 3 ratio. Okay. DC to CE, this one is to this one. This ratio is a 1 to 2 ratio. Okay. Now, let's follow their logic for a second. The ratio of K to M. Okay. Now, what is the ratio of K to M? Well, I made K the length of 1 inch. And I made L the length of 1.5 inches. Okay? So that this would have a ratio, okay? Because 1 to 1.5 is also 2 to 3. If you multiply the 1.5 times 2, you get a ratio of 2 to 3. Okay? Now, M is 3 inches long. Because we wanted M to be twice as long as L. Okay, so 1.5 times 2 is 3. So what is the ratio of K to M? Well, K to M is 1/3. Alright? Now, I'm not sure what they mean by compounded ratios. Okay? But basically, you're getting all the facts here. Okay? So the ratio of K to L is 2 to 3. The ratio of L to M is 1 to 2. So, I'm going to have to do some research on this. And when I do, I'm going to post an additional video. But basically, you've seen the proof now, so you know what this is. And I'm going to talk about compounded ratios in a separate video. But you actually now have seen the proof. You now have the numbers. And now, when I talk about compounded ratios, you'll understand what's going on. Alright, I will talk about compounded ratios in a separate video, and I will tell you guys more stuff in future videos, so stay tuned.